This is a re-recording of the lecture from November 28th. The audio for that lecture did not work, so I'm re-recording it so that it can be online nonetheless. So we're doing invalidities today. Invalidities. Recall the concept of validity, that is, an argument is valid if and only if it's impossible for the premises to be true while the conclusion is false. This concept has been sort of in the background of everything that we've done with derivations, because derivations demonstrate validity. They show that if you assume that the premises are true, then the conclusion must be true also. Now, that's great if what you want to show is that an argument is valid, but what happens if you get halfway through a derivation and can't seem to solve it? Does that demonstrate that the argument is in fact invalid? Well, not really, because it's always possible that maybe you just can't figure out how to solve it. I mean, it happens to the best of us, that you get halfway through a solvable derivation and can't figure it out. So failing to come up with a derivation isn't really proof that the argument is invalid. What we're going to do today is a method for demonstrating, for proving the invalidity of an argument in a kind of conclusive way. Now, we have seen something like this before. So remember back in sentential logic, we had these truth tables. And a truth table is one method for showing that an argument is invalid. You just fill out all the truth values for all of the parts of the argument. And if you could find a line on which all of the premises come out as true and the conclusion comes out as false, then you've shown conclusively that it's possible for the premises to be true while the conclusion is false. So this is a kind of proof of invalidity, and we're going to do the equivalent version of this for predicate logic today. So to demonstrate an argument is invalid in predicate logic, it's similarly enough to show that there's a possible situation in which the premises are true and the conclusion is false. But in predicate logic, we're no longer just talking about sentences, we're talking about the properties of things. What makes a sentence in predicate logic true is whether a property applies to a thing or not. So thinking up counterexamples can be hard, it can be complicated, and we're going to simplify this process for ourselves by restricting what's called our universe of discourse. So previously, when I was explaining the meaning of the quantifiers, I would make these expansive hand gestures and say things like, for everything in the whole universe, something, something, something. So that was our explanation of the universal quantifier. When we're doing these invalidities, I mean, the whole universe is a pretty large thing to be dealing with. It's pretty complicated, and you don't want to have to write down all of the things in the universe and go through them one by one. But if we restrict our universe of discourse, if we say we're just going to talk about a few things, and then we're able to show that the argument is invalid just taking a few objects with a few properties, then that argument is invalid. We've shown deductively that the argument is invalid, and that will continue to hold for a larger universe of discourse. So that's what we're going to do. Often it's the case that when we're trying to show that the premises could be true while the conclusion is false, remember, we're trying to demonstrate that it's possible that this could be the case to show that the argument is invalid. And if you can show that it's possible in a small universe of discourse, then it's likewise going to be possible in the total universe, the large universe of discourse. So let's start with a very small universe. It's got three things in it, exactly three things. It's got this shoe, it's got this string, and it's got Henry the dog. So a really small universe, just three objects. Now, suppose that we've got the following two predicates. Something is green and something is footwear. So A is green and F is A is footwear. Furthermore, we've got the following argument, three premises and a conclusion. And we want to know if this argument is valid. So the way to demonstrate deductively that the argument is invalid is to come up with an example, come up with a set of objects that can make the premises true while the conclusion is false. So let's just ask ourselves one by one whether these premises are true and then whether the conclusion is false, given these objects and the properties that they pretty clearly have. So, premise 1 says there exists an X such that Fx, that is, there's something that is footwear. So there's a shoe, shoes are footwear, so good. There exists something that is footwear in our tiny little 3-object universe. So premise 1 is true. Premise 2 says, for all things, if they're footwear, then they're green. So we go through our list of everything that satisfies the F predicate, that is, so far, just the shoe, right? The string is not footwear, Henry the dog is not footwear, so the only thing is this green shoe, and that shoe is green. So premise 2 is true, because all the objects that have the F predicate also have the G predicate. Good. What about premise 3? There exists something that doesn't have the G predicate. There exists an X such that not GX. And that says there's something that is not green. Well, Henry the dog is not green, so good. Premise 3 is true because there exists something that doesn't satisfy the G predicate. There's something that is not green. Okay, so now we've got that all 3 of our premises are true given these predicates and given this universe of discourse. Now how about the conclusion? If this argument is invalid, then it should be possible that the premises are true while the conclusion is false. So we want to check whether this conclusion is true or false. The conclusion says, for all X, if X is green, then X is footwear. Well, if X is the shoe, then this is true, right? So if we plug in the shoe for X, we say, is it green? Yes. Is it footwear? Yes. However, with the string, we have, is it green? Yes. Is it footwear? No, because string is not footwear. So there is something that we can plug into this X variable that makes the conditional false. The conditional is false if the antecedent is true and the consequent is false. So if we plug string in for that X, we've got a false conditional, and therefore the universal generalization itself comes out as false. So it's not the case that we could go through the whole universe of discourse plugging in any object that we want and have the conditional always come out as true. So what we've shown then is all 3 premises are true and the conclusion is false. Therefore, this argument is invalid. Okay. So that's the basic method of showing invalidity. We're going to pick out a universe of discourse, and we're going to apply properties to the objects in that universe, and then we're going to see whether that universe of discourse with those properties can make the premises true while the conclusion is false. Okay, so dealing with objects like shoes and Henry the dog is a bit cumbersome. It's a bit complicated. So we're going to simplify this for ourselves a little bit. First simplification is we're going to explicitly list all of the properties that our objects have, so all of the objects that fall under the property. So we explicitly list out in these curly brackets our UD, our universe of discourse. The universe of discourse tells us all of the things in the universe. And then for each of our predicates, we're going to list out all of the things that satisfy those predicates. So F is footwear. That means we create a list of all of the things that are footwear, that this property applies to. In this case, it's just the shoe. And then we list out all of the things that G applies to. So G is green, and the shoe is green, and the string is green. So G gets shoe, string. Okay, the next simplification we're going to do is to not even use the names of objects at all. So the thing on the left is equivalent to the thing on the right. What we've got here are, on the right, a universe of discourse with 3 objects, and the numbers are going to represent our objects. So instead of writing out shoe, string, dog, we're just going to write out 0, 1, 2. This kind of cleans things up and makes it easier to keep it all in your head. So 0 represents string, 0 represents shoe, 1 represents string, 2 represents dog. So when we're listing our universe of discourse, it's just curly brackets, 0, 1, 2. When we're listing our predicates, you just put the numbers of the objects that fall under those predicates. So we're saying that the object 0 has the F property, being footwear. The objects 0 and 1 have the G property, being green. And then with names, we can just say this name applies to this object. So number 2 is the thing picked out by the name Henry the dog, or K. So from now on, the thing on the right, these numbers are the only thing that we're going to deal with. We're going to keep this really simple for ourselves by not talking about real objects where it's unclear whether it has the property or not. We're just going to say, here are some objects represented by numbers, and explicitly say which properties those numbers have. So let's do this in action to make it clear what the actual activity is going to be. So what you're going to see on the exam is an argument, 3 premises or a few premises and a conclusion, and I'm going to say show that this argument is invalid using the invalidity method. So the goal here is to show that this is true, and this is true, this is true, and this is false. So we're trying to figure out a universe of discourse with some set of properties that makes all the premises true while the conclusion is false, and that will demonstrate invalidity. So to set this up, you need a few things. You need a universe of discourse. Let's open up a curly bracket for that. And then you need a list of all of the properties. So we've got the F property in play, we've got the G property in play, and we've got the H property in play. We're just going to open up sets for each of them, and then the method is going to be to slowly add objects to the universe of discourse and say that certain properties apply to those objects such that we can make each of the premises true while the conclusion is false. Okay, and we need at least one. We'll make it a rule, you need at least one object in your universe of discourse. We'll start with 0. Okay, so now we've got an object, and our task is to make these premises true. Let's just take them one by one. So premise 1 says there exists something that is F and it's not G. There's something that has the F property and it doesn't have the G property. So we've got one object so far. Let's make it have the F property. So I've written 0 in here. What I've said is of this object in our universe of discourse, 0 has the F property. So if I plug 0 in here, it comes out true that F 0. And I have to make it the case also that this object, 0, doesn't have the G property. So I can do that by just not writing 0 in this column. I'm going to make a little note for myself to remind me to make this not to put 0 in here. Because if I put 0 in here, that'll make this premise false. So this isn't part of my answer. This is just a note to myself. So note to self, don't make 0 something that G predicate applies to. Good. So now we've made premise 1 true. Okay, let's try premise 2. So for all x, if x has the H property, then it doesn't have the G property. Okay, so recall that a conditional is true if the antecedent is false. So if nothing satisfies the H property, then the whole conditional comes out as trivially true. Currently, we've got nothing under the H property. So currently, premise 1 comes out as trivially true. So that's fine. We don't have to do anything to make this premise true right now. Good. Now let's move on to premise 3. So there exists something that has the H property and the F property. Okay, so now we need to put something to make it true that something has both the H property and the F property. We need to put something under H. Can I say that H is 0? Yeah, let's try it. So let's try it and see what happens. And every time you add something to one of these elements, you kind of have to check. You have to go back and check whether you've made one of the previous premises false so that your changes don't ruin the work you did before. So we've added 0 here. That makes it true that something has the H property and the F property. 0 has the H property and 0 has the F property. So good, now we made this premise true. We just have to go back and check to make sure we didn't ruin any of our previous work. So it's still true that something has the F property and doesn't have the G property, that's 0. It's still true that if anything has the H property, then it doesn't have the G property. Now this isn't just trivially true because at least one thing has the H property, but that one thing doesn't have the G property, and we've made sure to do that. So good. We did not ruin our previous work by adding 0 to the list of things that has H. So excellent. We've got premise 1 true, premise 2 true, and premise 3 true. Now, the job is to make the conclusion false. So we have to figure out a situation in which this conclusion comes out as false. And the only thing that makes a conditional false is, of course, when the antecedent is true. So we need something, call it phi, that's F, and we need something that is G. So if the antecedent is true, then there's a thing that's F, and it's false that there's a thing that's not G. So we need a thing that's G as well. So we need something to be both F and G in order to make this conditional come out as false. So we need to pick out an object that we can make both have the F property and the G property. So good. Well, what about 0? Can we get by plugging 0 into this? Well, no, we said before that we're not going to make 0 have the G property. That's how we get this premise to come out as true, right? There is something that's got the F property and not the G property. So we're saying don't make 0 have the G property. But we need nonetheless to make something have the F property and the G property. So now it's time to add another object to our universe of discourse, 1. And we can say, let's choose 1 as our thing that has both the F property and the G property. So now we've got that there's a thing that satisfies the F predicate, so this antecedent comes out as true, but it doesn't fail to satisfy the G property, which is to say that it does satisfy it. So there's a thing for this conclusion says, for everything in the universe, if it's got the F property, then it doesn't have the G property. To make it false, you need something in the universe such that it has the F property and it does have the G property. And now we've done that with 1. Okay. So one more time, we're going to go through. So now we've made the conclusion false. One more time, we're going to double check to make sure we haven't made any of the premises false as well. And if we haven't, then we've succeeded. We've come up with a universe of discourse and applied properties to that universe such that the premises are true and the conclusion is false. So one last double check. Does there still exist something that has the F property and doesn't have the G? Yes. 0 still has the F property and it doesn't have the G. Because this is an existential, we don't need this to be true of all our objects. We just need there's at least one thing that has F and doesn't have G. Okay. Now, is it true that for anything that has the H property, it doesn't have the G property? Yep, that's still true because the only thing that has the H property is 0. 0 does not have the G property, so good, that's still true. And it's still true that there's at least one thing that has the H property and has the F property. 0 still has the H property and it still has the F property. So good. Now we've come up with a situation in which all 3 premises are true and the conclusion is false. And what we can do to show that we're done is just close off these sets. Hooray. We've done it. So that was showing invalidity. What we've done here is generated a universe of discourse and applied these properties to the objects in the universe and said, of these objects, which properties do they have? Well, 0 has the F property and the H property. 1 has the F property and the G property. And given this universe of discourse and these properties, these 3 premises come out as true and the conclusion comes out as false. Therefore, this argument is definitely invalid. We've proven that this argument is invalid. And you'll never ever, if you plug this into Logic 2010, you will never ever be able to come up with a derivation that starts from these premises to these conclusions. Okay. Let's do another example. Right. So remember, once again, I mark these as TTF because I have this chronic problem where I get in the groove of showing these things are true, and then I forget I'm supposed to show the conclusion is false. So I write these to remind myself that my job here is to make this false. Okay. So once again, we're going to set up our universe of discourse, put at least one object in it, and then we're going to create lists for all of the predicates that we've got. So A predicate has got a list, the B predicate has got a list, and the C predicate has got a list. Okay. Now, the thing is just to go through one at a time. Oh, sorry, and we also need something for K. So K needs to be something, or K is going to act as a name here. It's just going to stand for some object. Okay, so the procedure, once again, is just to go through each premise one at a time, making it true, and then making the conclusion false. So premise one is a universal generalization containing a conditional. So if anything has the A property, then it has to be biconditional that it's got the B or the C. So if anything has the A property, then it both has B and C, or it has neither B nor C. That's just what the biconditional means. So once again, a conditional is trivially true if nothing satisfies the antecedent. Currently, we've got nothing under the A predicate, so this premise one comes out as trivially true. So that's good. Premise one is trivially true right off the bat. We don't have to do anything right now to make this true, so we can just move on. Now, BK and not CK. This says the thing that's K has the property B and it doesn't have the property C. So what we need to do is assign K to something. So this is standing in for some object. We'll say we only have one object so far, so let's say K stands in for 0. And now what the sentence says is 0 has the property B and 0 doesn't have the property C. So we add 0 into our list of things that have the property C, and just make a little note for ourselves that it's not going to, in order to make this conjunction true, both halves have to be true. So in order to make not CK true, it has to be the case that C does not have the property 0. Okay. So far so good. And have we made any trouble for ourselves by making those moves? Have we made any trouble for ourselves with premise one? Well, no, there's still nothing under the scope of A. So there's still nothing that satisfies the A predicate. So this remains trivially true so far. Okay, good. So now we've got premise one is true, premise two is true, and all that remains is to make the universal generalization of the conclusion false. Okay. So what would make it the case that for all x, not ax, is false? This says everything in the universe does not have the A property. Well, is that true right now? Well, yes, right now it's true that there's nothing in the universe. So for all things that are in our universe of discourse, there's only one, but for all things in the universe of discourse, they fail to have the A property. So currently this is true. That's bad for us. We want to make it false. So we need to put something under the A predicate. Now, we could potentially put 0 under the A predicate. So let's try it and see what happens. So if we put 0 under the A predicate, then this comes out as false, right? It's no longer true that everything in the universe fails to have A. There's at least one thing that has A. Now we have to go back and check whether that makes trouble for any of our previous moves. So this is worrying, right? So because we've got the something falling under the A predicate, now we have to, this is no longer trivially true. We have to figure out whether it's true given this setup. So 0 has the A predicate. So for all x, that is plugging in anything in our universe of discourse, this is supposed to be true. So plugging in 0, so A has the property 0, good. Then a 0 has to either both have B property and C property, or neither B nor C. Okay, so currently 0 has the B property but not the C property, and we even made a note for ourselves not to add in 0 here, right? So because that would mess up our story here. So it's going to be tricky. I'm not allowed to just write a 0 in here to make this biconditional true. And furthermore, I'm not allowed to erase this 0. We needed that to make this part true. So 0 is not going to be the right thing to plug in here. So we made a 0 in order to make this false. But we can't use 0 to do that. So the thing to do here is just to add another object and make the object 1 our thing. So, okay, how are we doing now? We've got, currently there is something that satisfies the A predicate, so it's false that for all x, not AX. So good, that's good. Now we just go back and check what this does to the rest of our stuff. So for all x, if something has the A property, so 1 satisfies the A property now, so good. And if something satisfies the A property, it's got to both satisfy B and C, or neither B nor C. So currently, the only thing that satisfies this A property is 1, and neither B nor C have the 1, or neither B nor C are apply to 1. So currently, this thing is true. So good. Another way that we could do this is so basically we're done now. We could close off all these brackets. So if you just say close brackets, this is a valid solution. Sorry, this is a solution to the invalidity. That is, we've got a universe of discourse containing two members. 1 is the only thing that satisfies the A predicate. B is the only thing that satisfies 0 is the only thing that satisfies the B predicate. Nothing satisfies the C predicate, and K is a name for 0. And we've made the first two premises true and the conclusion false. Another way we could have solved this, so there's another way of getting this to be true. If we make B and C both contain 1, this would have been a good answer as well. There's nothing wrong with this. This is in fact the answer they give in the textbook. So what we've done here is to say, to make this biconditional true, we say if something satisfies the A predicate, then it both satisfies the B and the C. So now something, number 1, satisfies the A predicate, and it satisfies both the B predicate and the C predicate. So this would have been a good answer too. There's possibly multiple answers, and the strategy I recommend is basically just to build up piece by piece your universe of discourse. When you get stuck, add a new member and make the premises true one by one, and always keep going back and checking whether each move you make ruined previous work that you did. And it might take some back and forth. It might take some guessing and checking, revising, and that kind of thing. Okay, let's do one final example. Okay, so I want to make this true, this true, this true, this true, and this conclusion false. As always, we're going to set up a universe of discourse and then a list for each of the properties in the argument. So J needs a list, K needs a list, H needs a list, and we need something for, we've got a name here, which is C. Okay, so we add at least one object to our universe of discourse, and then just start asking ourselves, are these premises true? And if they're not true, what do I have to do to make them true? So in this case, what do we got? We got a universal generalization with a conditional in it. If nothing satisfies the antecedent of a conditional, then it's trivially true, it's automatically true. So currently nothing is under the J predicate, so good. This comes out as automatically true without us having to do anything. Okay, cool. Now, premise 2. It's not the case that for all x, if it's not kx, then jx. Okay, so you can feel free, if you get something complicated like this, feel free to manipulate it a little for yourself if you find that it helps you. So we can do, for example, quantifier negation on this. We can say there exists an x such that it's not the case that not kx, then jx. you can do any of your standard manipulations. So what I've just done is written out something logically equivalent, but maybe it's easier for me to read out. Similarly, we can say this, we can just do negation of conditional on this. So we can say not kx and not jx. Okay, so I'm just writing out logically equivalent versions of this, trying to get myself something that I find more intuitive and easy to read and easy to evaluate. So there's a lot of, these two negations might be confusing for you. If it's straightforward, then you don't need to do this, but I find sometimes it's easier to manipulate these premises into things that I recognize and can think through. So this premise now says there exists something that is not k and is not j. Okay, well, there's a 0. 0 exists, so that satisfies, we can plug in 0 for here, and 0 doesn't have the k predicate, nothing has the k predicate, and it doesn't have the j predicate, nothing has the j predicate. So once again, this comes out as automatically true. Notice that we did need at least one object in our universe of discourse to make this true. So there exists an x requires that there's at least one thing. So we did need this 0 here in our universe of discourse, but we didn't need to add it to anything. In fact, it's better if we don't to get this one to come out as true. Okay, great. So premise 1 is true, premise 2 is true. Moving on. Premise 3 says there doesn't exist something that has the k property and doesn't have the h property. So there doesn't exist anything that has this and doesn't have that. Well, okay, so to make this true, you'd need both sides of it to be true. And there doesn't exist a thing, currently there's nothing with the k property. We didn't plug anything under the k property. So there doesn't exist a thing that has both of these. Well, good, yeah. I mean, certainly there doesn't exist anything that has both of these because there's nothing that has this. So once again, we've already got this to be true just by doing nothing here. So premise 3 is once again true without us adding anything anywhere. Okay, good. We do need to do something with C. C is a name, so we need to apply C to some object. We say C represents the object 0. So C is the name for 0. So if this says if C has the property H, then there exists something that's got the property J. Okay. Well, to make this true, we can make this conditional true just by making the antecedent false. We can make the antecedent false just by not writing 0 into the H property. We just don't say that H has the 0 has the H property. That means that C doesn't have the H property because C is the name for 0. And this thing comes out as true. So, great. Our 4 premises are all true. Without us having done anything, our 4 premises are all true. Okay, now we just need to make the conclusion false. Once again, feel free to write things out for yourself in a clearer way. I mean, to make this false, this is a negated existential, to make it false, you just make the existential true. So I just want to make it true that there exists something that hx or not jx. So, okay, there exists something, 0 exists, that either has the h property or doesn't have the j property. Well, 0 doesn't have the j property, so this whole thing comes out as true if we plug 0 in for x. And if this thing comes out as true, then the negated version of it comes out as false. So there you have it. We've done our invalidity by not doing anything. All we did was say there's one object with none of the relevant properties. Its name is C, and now all 4 premises come out as true and the conclusion comes out as false. This kind of solution is exactly why I recommend doing this step-by-step thing. So don't try to imagine, don't like look at all the premises and try to imagine a situation in which the premises are true and the conclusion is false. Do this step-by-step, building up the universe, adding things only as necessary and testing at each stage whether it works. Okay. So that's pretty much it. The only other thing I'd like to do is show you the controls for Logic 2010. We didn't quite get to this in class, so I'm glad I get to do this in the redone video. So here's an invalidity in Logic 2010. Invalidity 3.113. It says, it's a theorem, that is, there's no premises, and this is the conclusion, meaning if it's a theorem, then you don't have to do any work to make the premises true. You just have to make the conclusion false. So what we're going to do is try to make this thing false. And we'll start with our universe of 1. So we've got 0 in the universe of discourse. And we need to just do whatever is necessary in order to make it false, that for all x, if x has the property f, then for all x, fx. So right now, so to make this conditional true, we would need, or to make it false, we need the antecedent to be true and the consequent to be false. So we need it to be true that there exists some x such that fx. So let's say I click on the, so once again, so I click on this thing to open up a window, and by clicking this checkbox, what I've told it is that 0 has the property f. And now it adds this 0 under this property f. Good. So now we've made the antecedent true. It's true that there's some object that has the property f. Now we need to make this consequent false. Currently it's true though, because for all the objects in our universe, those objects have the f property. So we need to make at least one more object that doesn't have the f property. So I'm going to revise the size of my universe of discourse up to 2. Now we've got 0 and 1. Okay, so now what we've got, check to see whether that did the trick. Sometimes just adding an object to the universe of discourse can solve your problem. So we've got it the case that if you plug in 0 for x, then f has the property x, but it's false that for all x, fx. It's false that all of the objects in the universe has the property f, because we have not said that 1 has the property f. So if I click on this again, now it's giving me, because I've increased the size of my universe of discourse, it's giving me the option to say that 1 has the property f, but I don't want to do that because this is the solution to my problem. Now what I've got is, for all x, if you plug in f, or 0 for x, then yes, 0 has the property f, but it's not then the case, so that part can be true. You can make this true on some assignment, and this is false, because it's not the case that everything in the universe has the property f. So check, and hooray, I did it correctly. So those are the controls. We're just clicking here to change the size of the universe of discourse, make it as big as you want, as big as you need, and then clicking here to say whether each object has that property or not. Okay? So that's the controls for invalidities in Logic 2010.